Hello, my name is Advait, and through this video, I will give an introduction to Open Biohit Plus, an open source pipetting application. Link to the package and documentation can be found below. Once the application is opened, a blank canvas with default deck and three different tabs can be seen. Deck building is mostly done in the deck editor and low level parameters tab, whereas pipetting operations are handled in the operations tab. The deck info can be seen by clicking on deck info. All these values are in millimeters. You can always create a new deck by going on file and clicking on new deck. Make sure the values fit the real dimensions and click on create. To resize the canvas, you can click on refresh deck and it will resize according to the window screen. Once the deck is configured, it's time to create slots. Slots are individual positions on deck that are fixed and that hold labwares. To create a slot, press create slot. All these values are again in millimeter. Slot ID is an integer, so any number would work. Once a slot is created, you can edit the slot, you can delete the slot, or you can place the slot on deck. Another way to place the slot on deck is to double click it. Once the slot is placed, it should show up on the canvas. You can select the slot by clicking on the object, and you can also watch the parameters of any object placed on the canvas like that. To unplace a slot, you can either click on unplace slot button or triple click the slot itself. Once all the slots are created and placed on deck, it's time to create Labware. This can be done in the Labware section here. The definition of each Labware type and the meaning and significance of their parameters are explained in the documentation. I'll show how to create a plate Labware as an example. Here size X, Y, Z are the dimensions. Offset X and offset Y is the distance from slot corner to the first well. Stackable is turned off since plate is designed to be the top Labware, but it can be turned on as well. Let's make a 48 well plate, so that 8 wells by 6 wells with add height as 5 mm from well bottom and remove height as 3 mm from well bottom. X spacing and Y spacing is the distance between adjacent well along the respective axis. Since plate require wells, a template well has to be created. If none exist or none applicable exist, you can always create a new one here. Again, the parameters of all low-level labwares are defined in the documentation. For example, here capacity can be provided and the shape can also be provided. If there is an initial content for the well, you can also define that here. This can be edited later on and I'll show you how. Once all of this is configured, it's time to create the labware. Other labware can be created similarly. Once the labware is created, it is possible to edit the labware parameters. You can also see the labware parameters through the selection info box. It is also possible to interact with the children labware. For example, for plate, it's the wells by clicking on view children labware. Here, each box represents individual well and their parameters can be seen here. The position is none right now because the labware itself is not placed, but once the labware is placed, each well will have its unique position. We can also interact with the content of the well through the dialog box here. So you can remove some liquid, or you can empty the well, or you can add some liquid. Similarly, it is possible to copy the content from one well and paste it to all or selected few. After making sure that the labware matches the physical reality, it can then be added to the slot. This is done by double clicking on the labware or by clicking on place on slot on deck button. Here you have to select the slot type and make sure that the slot is big enough to hold the labware. Even when placed, it is possible to edit some parameters of the labware and verify its structure. This can be done by clicking on the labware and clicking on edit children labware. Since the labware is placed, the position gets updated for each well. Once the pipettor is connected, you can move to that position and verify the position. Similarly, optimal Z height can be found by entering the Z height here and checking if that works. Furthermore, the aspiration Z height and the dispensing Z height can also be found by clicking on these buttons here and seeing if that is the optimal height you want. If that is not, you can always unplace the labware and change the remove and add height parameters and see if that works better. Lastly, it is possible to view / create more low-level labwares like well by clicking on the low-level parameter tab. Here you can see the labware created and see its information in the selection info box. Similarly, reservoir and individual pipette holder will be populated here. The current deck can be saved by clicking on File, Save Deck. Similarly, an old deck can be loaded by clicking on Load Deck here. We will use deck 2 throughout the remaining video. Once the deck is loaded, you should confirm if it matches reality. Things to confirm include the deck info, all the slots, all the labwares, and all the low-level labwares. You should also confirm and validate the structure and position of the labware and its children. For plate, like said before, position for random wells and remove and add height should be tested. Same must be done for reservoir holder and pipette holder. Reservoir holder actually have a very similar children dialog box as plate. This is because they share the content attribute. However, reservoir holder can have unique reservoirs, whereas plate is required to have a template well. For pipette holder, on the other hand, the main attribute is has tip attribute, which indicate if a tip is present or not. You can always change a specific holder and make it have a tip or not. Copy and paste works as before. For tip drop zone, validation is very easy as it has no children. So all you have to do is go to the position and see if the remove height is as expected. You can always unplace any unwanted labware by triple clicking on the labware or clicking on unplace labware. Here stack was used to raise the height of the previous labware, like the previous pipette holder, and make it accessible for the machine. I will place the labware back again. This is done by double clicking on the labware and selecting the slot. This Z height here is the height of the top labware present on the slot, so pipette is stuck here. Once added, the labware should be on the canvas, and this concludes all the deck editing tools we have. I will quickly go on how to connect to the pipette and how to set some parameters. This is done in the low level parameter tab. So here you can configure the pipette connection. You have tip volume, tip length, multi-channel or single channel mode, whether you want to initialize or not, and whether you want to use a mock pipettor or not. Since I don't have connection to the pipettor, I'll use a mock pipettor and press the connect to pipettor button. I can later on set some any runtime parameters here. I can also set some implicit parameters here. All of these parameters are defined in the documentation in the configuring the pipettor section. Additionally, one more thing to note is if you load a new deck or if you create a new deck, you would have to connect to the pipettor again. This is because deck reference is passed to the pipettor, and it is important to renew the reference, because otherwise a wrong reference would mean that the interaction is not made properly and as expected. So once that is done, you can move to the operation section. You can either work with a custom workflow or you can run independent direct operations. I'll go over direct operations first. The tip management operations are those that concern themselves with the pipette holder. The current state of the pipette holder can be seen here. Right now, all the individual holders have tips with them. The first operation here is called pick tips, which is basically picking the tip from the pipette holder. Once the Once the well window is open, you can either select any individual holder or you can auto select by pressing enter. I will select A3 for an example. Once the operation is made, it has to be validated and executed. You can press enter twice for that. Since the pipettor interacts with the labware in real life, the software also imitates that. So the pipette holder, as you can see, does not have tips at that location now. Return tip is just opposite of pick tip and involves returning the tip to that individual holder. Since all the other holders have tip, only one can be selected right now. Once the selection is made, you have to validate and execute the operation. Replace tip is a combination of return tip and pick tip. But it does require the pipettor to have tips in the first place, so I will do that. And now I can return the tip and I can run replace tip operation. The last operation here is called discard tip. This involves discarding the current tip to the tip drop zone labware. It's the most simplest operation there is. Once created, you can validate and run the operation, and you will see that the pipettor has no tips and there is one tip missing from that pipette holder and is lost to the tip drop zone labware. The application also allows for some basic system level operations. These are found in the system heading here. All these operations are really useful when troubleshooting the pipettor or when working with the pipettor for the first time. Moving on, the most important operations are the liquid handling operations. Here, add medium means adding said amount of medium to the wells from the reservoir. So basically it involves specifying the amount of liquid you want to add per well, let's say 500, and then selecting the reservoir you want to add it from, let's say A0, and then selecting the wells you want to add the liquid to. I'll select the first row for example. Once the operation is made, it has to be validated and executed. So basically all the liquid handling operation will only work once the pipettor has tips, so I'll quickly do that. Now when I do that operation, it should work and there should be no error message. I can also verify if the operation worked through the software by clicking on the labware and seeing if the selected wells have more liquid. So as you can see, it has 500 more UL than the remaining ones. Similarly, that reservoir will have some less liquid than the remaining ones, than the rest. The next operation is called remove medium. It is just opposite of add medium, wherein you remove from the wells and add to a reservoir. Add medium was a one to many operation, whereas remove medium is many to one operation. So I'll quickly reverse what we did in the first step. As you can see, or as you should see, that the state of the plate is restored. The next operation here is transfer plate to plate. This is a one-to-one operation where you can transfer from wells, from one well to another well, instead of transferring from a reservoir to a well. I'll do a transfer of 500 from the first column to the last column. The order of selection really matters here, and it also matters that the number of selection made in the first section matches the number of selection made in the second section. Once the operation is made, you validate and run the operation. You can again verify if the operation worked by clicking on the edit children labware button. The last operation in the liquid handling is called remove and add batched. So basically this operation is particularly useful when the well must not be without liquid for a long period of time. It is a combination of remove medium and add medium. So what we do here is we do the operation in batches, and we remove the medium of a few set of batch of wells, and then we add it just after, so it removes the time between removing and adding medium. I will show how that works quickly. So I'm gonna remove and add 500 UL. I'm going to remove 500 UL from the second column, and then I'm going to remove it to A0 Labware, and then I'm going to add 500 from A6 to the same column. Yes, the operation fails because the reservoir holder has no available volume left. So but if I empty the reservoir holder, it should work properly. As you can see, it did work. I will also go over some attributes of the liquid handling operation. This includes changing tip between wells and mixing. If turned on, the pipettor will discard tips between every well to the tip drop zone if this labware is present. If not present, the pipettor will return the tip to the pipette holder and pick a new tip. If mixing is turned on, the pipettor, after dispensing to the well, will aspirate and dispense the said amount of liquid again, essentially mixing the dispensed liquid. All the details about the operation and what is expected of them is explained in the documentation here. There is also a start measurement feature. This feature allows you to run a batch script file after a period of incubation and is really useful in taking measurement, especially during acute drug testing. The batch script file can be configured here. Now we'll go to the workflow section. So to create a custom workflow from scratch, you click on the create button here. In the workflow builder, the leftmost section is the list of direct operation, the center is for choosing parameter, and the right is for the list of created operations that can be validated and executed. Operation logic and the way of making an operation remains exactly the same. It is important to know that the well window is not restrictive here. What I mean by that is if I go outside and if I try to make a pick tip operation, I would not be able to select A0 since it does not have a tip at that position. However, inside the workflow builder, I can select A0. Of course, the validation would fail and the user would realize that there's a problem here. Now he can either edit the operation and select another well or alter the workflow such that the current problematic operation is executable. In our case, the user can always pick tip from some other location and return the tip to position A0. And if the user then reorders the workflow such that picking tip from A0 is after returning tip to A0, validation will not be an issue. The button here helps with the workflow building and working with the workflow in general. I here stands for information. This stands for reordering the operation. This stands for editing parameters, and the last one is for deleting deleting any individual operation. You can always copy the selected operation and paste them at specified location. The create button here stands for creating and saving the workflow to the application. Clear removes the workflow queue. Remap, I'll explain remap once I close the workflow builder actually. Validate and execute is for executing the operation, and once the operation is executed, it is also saved to the application. As can be seen, a random string is given to the workflow if it's not named. Workflows are made up of operation, and each operation is heavily reliant on the labware and the labware ID it interacts with. To make a workflow really usable, it is essential to replace one labware with another with relative ease. The remap feature is made with that in mind. I will add another pipette holder to the deck and will show how to use the remap feature. So now when I open the workflow and click on remap, I will see another labware, all the other labware of similar types. I can remap like that and I will see that we are using the new labware and are not using the old labware anymore. Lastly, it is advised to save the workflow to a local copy since all the workflow saved in the application gets lost when a new pipettor connection is made. Working with a multi-channel pipettor, everything else but the selection window remains the same. What I mean is that instead of working with one well or one individual holder, I would be working with a set of 8. Everything else, the way to build operation or workflow or edit deck, remains the same. Please go through the documentation for more details about any aspect of the application. Thank you.